this video, we're going to talk about how to use the normal curve table or the z-table to solve problems. The z-table that you have will tell you the amount of area between 0 and a positive z-score under the standard normal curve. To find specific sections of area, first, draw the normal curve with the mean directly in the center. So that would be like this. And your mean is going to be 0 for these problems because we're just going to be looking at standard normal curve problems in this video. Second, mark down the values or z-scores mentioned in the problem and shade in the area you need to find. 3, decide how to use the z-table and make use of facts about the normal curve to find the area. Let's look at an easy example first. Here we want to find the area between z is equal to 0 and z is equal to 1.42 under the standard normal curve. So the first thing we would do is draw a picture of our normal curve. Mean is directly in the middle. The mean is 0 because we're told this is the standard normal curve. And we want to find the area between 0, which we've already marked down, and 1.42. That's a positive 1.42, so it falls above the mean. And now we're going to shade in the area we need to find. So this piece of area right here is already between 0 or the mean and a positive z-score, so that means we can look it up directly on the table. So we want to find the area between 0 and 1.42, so we need to look up 1.42 on the table. So we'll go over here to 1.4, and then we have 0.02 is the next piece, so we need this. Now what we're going to do is follow this column down, and we're going to follow the 1.4 column across until they intersect each other. And that tells us that this piece of area over here is equal to 0.4222. If they asked us what the percent of area was, we would say it's 42.22%. There's another problem. Here we want to find the percent of area between z is equal to negative 1.42 and z is equal to 1.2 under the standard normal curve. First thing we would do is draw our picture. Put our mean directly in the middle. Now the z-scores they gave us were negative 1.42, so that's going to fall below the mean, and z is equal to positive 1.2, that will fall above the mean. And now we're going to shade in this area. We can't just look up this area right away from the table because the table only tells us areas between 0 and a positive z-score. So we can find the area between 0 and 1.2. The area between 0 and 1.2, we would just go to 1.2 and then 0.00, and that's going to be 0.3849. So the area in this half is 0.3849. Now we would want to find the area in this piece. Problem we have, the table doesn't give us negative z-scores, but if we remember from the last video, one of the facts about the normal curve is that it's completely symmetrical. So the area between 0 and negative 1.42 will be the same as the area between 0 and positive 1.42. They're perfect mirror images of each other. So in order to find this piece of area here, what we're going to do is look up the area between 0 and positive 1.42, which we did before. Again, we could follow this column down, we follow that row across until they meet up. This piece here is 0.4222. Now to find the total area, we just add these two areas together. And we get 0.8071, but the problem said find the percent of area, so we'll change this to a percent, which is 80.71%. Now let's say we want to find the percent of area above or to the right of z is equal to negative 1.84. First thing we would do, draw a picture of our standard normal curve, put our mean in the middle. The z-score the problem gives us is negative 1.84, so we're going to mark that down. And we want to find the area above it or to the right of it, so we're going to shade everything to the right of that z-score. So this is the piece of area that we want to find. We can find the area between 0 and negative 1.84 the same way we would find the area between 0 and positive 1.84. So we would go to 1.8, go over to 0.04, follow this row along and then follow this column down until they meet up. So we know this piece over here is 0.4671. But now what we have over here, we don't have an upper end point. We were just told all of the area above negative 1.84. We don't necessarily know what's here. But this is where we need to keep another fact about the normal curve in mind. So if you remember from the other video we had, the total area underneath the curve is equal to 1, and each half above the mean and the half below the mean both have an area of 0.5. So from here you would need to know that this upper half of the curve has an area of 0.5. Now in order to find the total area, we would add these two areas together, and we would get 0.9671 or 96.71%. Here we want to find the percent of area below or to the left of z is equal to negative 1.84. So first we would draw our picture here. Put our mean in the middle, the z-score they mentioned, negative 1.84. We mark that down, and now we want to find the area below it or to the left of it, so we're going to shade everything underneath it. Now this is a little bit more confusing because we can't look up pieces of area like this on the table. However, we can find the area between 0 and negative 1.84. We had done that before. Follow this one across, follow this one down. So we know the area in here is 0.4671, and we'd like to know what this piece of area is. We know that this entire half of the curve here is equal to 0.5, and we can use that information to find this piece. So if we wanted to find the shaded area here, that's going to be equal to the entire 0.5 subtract this area over here. The entire 0.5 minus the area that we can look up on the table. So if we do 0.5 minus 0.4671, that gives us 0.0329. So 0.0329 is going to be the amount of area here, but they want that as a percent, so we would move the decimal over 2 places, and this is 3.29%. Now let's look at another example. Here we want to find the percent of area above or to the right of z is equal to positive 1.7. So the first thing we would do, draw this picture, mark our mean in the middle. Z is equal to 1.7 is the other z-score they mentioned, so we need to mark that down. And we want to find the area above this, so that's this piece of area here. So now this problem is fairly similar to the last one we looked at, except instead of dealing with a lower piece of tail area, we're looking to find the area of an upper tail. And we're going to find this one the same way that we did in the last problem, again because the normal curve is totally symmetric on both sides. We can't look up the shaded area here, but we can look up this piece of area between 0 and positive 1.7. So that's going to be 0.4554. And if we know the entire area above 0 is equal to 0.5, the area in this shaded piece is going to be 0.5 minus 0.4554, which is equal to 0.0446, or 4.46%. Here we want to find the percent of area below or to the left of z is equal to positive 1.7. So first thing we would do, draw a picture of the normal curve, put our mean in the middle. Z is equal to positive 1.7 is the z-score they mentioned, so we have to mark that down. Now they want us to find the area below this z-score or to the left of it, so we're going to shade in all of this area over here. So this is like the opposite or the inverse of the last problem that we looked at where we found what the unshaded area was. So the first thing we can do is we can find the area between 0 and positive 1.7. That's going to be, again, 0.4554. Now we would need to know, well, what's the area below 0 equal to? And again, we have that fact that each half of the normal curve has an area of 0.5. So we know this piece is going to have an area of 0.5, so the total area will be equal to 0.5 plus 0.4554, which is 0.9554, or 95.54%. Here we have another example. We want to find the percent of area between z is equal to 0.71 and z is equal to 2.09. First thing we would do here, draw a picture of our normal curve and mark down the two z-scores they mentioned. So we have 0.71 and then we have 2.09. And we want to find the amount of area between them. So this one is a little bit tricky because we can't just look up this piece of area on the table either. Remember, our table only gives us areas between 0 and positive z-scores. We can look up the area between 0 and 0.71, this unshaded piece here, or we can look up the area between 0 and 2.09, which would be this unshaded piece plus this shaded piece. And now we're going to have to make use of the fact that we can find those two values, and we're going to have to make use of some geometry in order to figure out what the shaded area is here. So this we can actually split up into the difference of the larger area minus the smaller area. So our larger area is the area between 0 and 2.09. That's this whole thing here, or if we were to include this piece here. And the smaller area we have is the area between 0 and 0.71, which is this area here. So if we subtract this area from this whole area between 0 and 2.09, we're just going to be left with the shaded piece. So the area between 0 and 2.09 will go to 2.0, and then up here 0.09, so we follow this one all the way across over here and follow this one down until they intersect. That's 0.4817. And now the smaller section of area between 0 and 0.71, we're going to go to 0.7 and then 0.01, follow this across, follow this one down, we get 0.2611. We subtract these two values, we end up with 0.2206, or 22.06%.